we'll do a couple examples of the types we've done so far. So the first was fraction or equals fraction or not. So I'll show you what I mean by or not. So we're just lumping this together. So example 1, 2x minus 5 over 3 is equal to 4x plus 1. This is the or not. So fraction equals something. All right. So how do we get rid of the fraction? Because that's what you do first. Multiply, cross multiply. So the only thing on the bottom here is a 3, so that's going to multiply on top. So we will have 2x minus 5 equals 3 onto 4x plus 1. Make sure you put a bracket there. You want to multiply it by the whole side. So 2x minus 5 equals 3 times 4 is 12. 3 times 1, 3. So 2x and 12x, that will be a minus 12x. 3 is on this side. The 5 is a negative, so move it over, becomes a positive. Minus 10x equals 8. You can simplify it. So first of all, the minus, I said you don't leave a minus on the bottom. You can write it either in front or on top. 8 over 10. They both divide by 2? Yeah. This is 2 and 4, and this is 2 and 5. So the 2's cancel. 4 over 5. Yeah, well here I divided both sides by negative 10, right, to get that. Do you see it? But you don't usually leave a minus on the bottom of a fraction. That's weird. So you put it on the top or in front.
You don't mind if we do it the other way around, like leave our x's on the right instead of the left?
No, don't mind at all. But your final answer has to be x equals a number. Okay, so her question was, if we brought the 2x over here to be with the 12, is that okay? And then did the same thing, and that's fine. It's just your final answer should say x equals, so you'd have to switch it around. Okay, so one more like that. X minus 1 over x plus 2 equals 3 over 2. So this is fraction equals a fraction. But again, it doesn't matter. Here, this would be a cross multiply, but you just have one thing to bring up to the other side, because only one side had a fraction. This has both sides of fractions, so what do? Bring the bottom up to the other side for both. So this 2x, or x plus 2 goes up here with the 3, and this 2 goes up here with the x minus 1. That way. And then multiply it out and solve. So 2x minus 2, 3x plus 6. This is not an answer.
You have to divide by -1.
Right, you have to change the signs or divide by -1, because that's a -1 in front of the x. Eight over -1 is also not an answer. You don't leave an answer with a divided by 1. Okay, so you do, yep.
What would happen when you subtract your x 0?
Oh, then you would write no solution. Did you start the homework? Yeah. Everyone heard that, right? Yeah. Yeah, if the x is all canceled, then there's no solution. I'll show you. Let's do one. Okay. So you set up the next line. You cross multiply. Just the 3, because there's only one fraction. Oh, shoot. This isn't going to do what I wanted it to do. I meant for it to, but I'll do another one after. It doesn't hurt to have an extra example. This isn't doing what I want. 3 times is 18. The x's aren't going to cancel. It's 12. Over minus 16, but don't leave the minus on the bottom. And does anything cancel here? Never. When the numbers are only one apart, they never will. You don't even need to check, because there's nothing that would go into two numbers that are... All right, let's do this again, that it actually does something. There. So cross multiply. So 4x minus 3 equals 4x plus 2. So if we bring that 4x over, (4x minus 4x), 0. No solution. Yeah, and I'm going to comment on that right now because I showed my 9- and 10-year-olds some of your tests. I don't know who you are, so I'm not making fun of any one person in particular. There's 120 people in our class, and it must be at least 20 that did 3 minus 3 is equal to 1. And you may have done it and not even know right now that you're one of those people. But it was so many people, not just one person by mistake. 3 minus 3. Grade 1 people. Grade 1. 3 minus 3 is 0, not 1. A lot of people did that. If you have 150 over 50, what's that equal? 3, yeah. 50 goes into 100. And if you had this, no need to even write the 3, because 150 over 50 minus the same number, 150 over 50, is 0. When you subtract two numbers and they're the same, does that make sense? That it's 0? 0. Like, not just 1 or 2 people. I should go through and count, because my guess is it's at least 20, but I could be exaggerating because I could believe how many I saw, so maybe less than that. I could be exaggerating because I felt like there was a lot of people, but I should go through and count, because there's a lot of you. And so I wrote a lot of times, 3 minus 3 equals 0. 3 minus 3 equals 0. 3 minus 3 equals 0. I wrote that a lot. You got a half mark out of 1 if you got up to the 3 minus 3, even if you put 1. Just for doing it right up to that point. But. Okay, so yeah, so sometimes it'll all cancel and just means there's no solution. What if the other way? What if the number cancels but not the x? What do you think?
Like if that would have been 2 minus 2 instead. So I'm saying for 2 loud anymore.
I think this will do what I want. Okay, so let's say multiply this 2 up here So x minus 4 equals 2 onto 2x minus 2. So x minus 4 equals 4x minus 4. Okay, so I'll let you catch up to there. This is okay. It's okay to have a answer of 0. Because now what you would do is divide both sides by minus 3. And x is equal to 0 over 3, which is 0. So the answer is 0. Remember, 0 over a number is equal to 0. A number divided by 0 is undefined. Those are two very different answers. If you get 0 as an answer, don't then write undefined. A lot of you did that, and then I had to take off a mark. Because 0 is not undefined. 0 is a number. It's 0. But you can't divide by 0. That's when you would say something's undefined. But a 0 on top of a fraction is good. That's okay. Okay, the next type, fraction plus or minus a fraction equals a fraction or not. So that's saying there's maybe 3 fractions in the question, but 2 at the minimum. So there's 2 fractions either added or subtracted, and then a third fraction, or it could be a number or just a term. Okay, so we'll do a couple examples like that. Okay. So what's the method? Common denominator. So when there's 3 terms like this, you have to get it so that it's like our first type, fraction equals a fraction. So you have to combine these to make one fraction first, and then you can cross multiply. So common denominator. Is 6, that's right. So we're going to multiply this one by 3 over 3. And just write it out. So this will be 3 times 2x minus 1. Oh, sorry. 2. Thank you. 3 times 3 is 9, not 6. There we go. 3 times 2 is 6. We don't need to change the second one because it's already over 6. And just rewrite the 1 because we're not changing that. You don't need all of them to have the same denominator. Just one side so you can combine them. This can now be combined as one fraction over 6. So now what? You could simplify the top here, or you could notice that it's a fraction equals a number and cross multiply. Either step. We can work this out. This will be 4x minus 2 minus 5x. 4x minus 5x is minus x. There. So now we have a fraction equals a number, and we can cross multiply. The 6 would go on top with the 1. Move the 2 over. And divide by negative 1. So just a comment, like I put an arrow here, that's because I was moving instead of going down. You won't obviously have that arrow if you kept going down on your page. But with equations, we want them written one line under another. You never put an equals at the front when the equals is in between it, and you don't put an arrow in front. Okay, arrows actually mean something else in math, and so some people lost marks for putting arrows instead of equal signs. You can't do that. on your last two assignments. You need if it's not an equation, your equal sign is in front, like your last two assignments in your test. And if it has an equal sign, then it sort of lines up going down the page. Okay? But one under another with nothing in front. That would be the normal way. Okay, so let's do a second one like that. So I'll let you write it down. Now this isn't, it doesn't look like the other one, fraction plus a fraction, but couldn't I rearrange it so that it was? Put the two fractions on one side, and then the other stuff on the other side, and then you'll be able to find a common denominator. So what I mean is I would move this over. So then you would have like x minus 4 over 2, and then bring this minus 2x plus 3 over 3. So, yep. Yeah. No. No, because I'm moving this fraction, so I moved the fraction and changed it to minus, which does change the top, but that's only once you have a common denominator that you would then change those signs. This I did change both, but I could have brought it over. How could I have brought it over as 1? If I had put this in a bracket, then I could have just put a minus sign in front and brought that over, but that would change the signs. Okay. So, but when you bring a whole fraction over, don't change the signs right away, because then you'd have to put a plus here, and then it would be minus and a minus, and that would be kind of weird. Bring the whole fraction over, put a minus in front. And yeah, you could have brought this one over and left that there. That would be fine as well.
So you would just put the x minus 1 over 1?
You could, yeah.
That's not big.
Yeah. So what's the common denominator? 6. So we need to multiply this one by 3 and this one by 2. And you notice when I do that, even though I wrote the 2 at the end, when I put it on top of the fraction, I put it in front of the bracket, and that's so you'll remember to multiply that out. So when we combine these now, they have the same bottom, so we make one big fraction, 3 onto x minus 4 minus 2 onto 2x plus 3. Work out the top. 3x minus 4x is minus x. Minus 12 minus 6 is minus 18. Now what? Oh, yep.
Why did that get switched to minus 6 to be 4x minus 6? Second one at the bottom?
Yep, right here. Minus 2 times 4, or minus, and minus 2 times 3. Any other questions? Okay, now what? Cross multiply the 6 times both of those, so you put it in a bracket. 6 minus x plus 1. Six times minus x is minus 6x, and 6 times 1 is 6. And then move things around. So minus x plus 6x equals 6 plus 18.
When I did mine it the other way, I ended up with negative 12 prime.
Yeah, you probably have something wrong there.
I would honestly say. Doesn't help that I didn't carry the grade down the whole.
There you go. Yeah, so if you do rearrange it to start different, you should still end up with the same answer, okay? Sometimes, like if you bring the x's to the other side, that I do, you'll end up with a minus and a minus, which will cancel and be a positive. That's one thing that will always happen. Okay, the signs will be all opposite of mine. Okay, so now let's start radicals.
Okay, let's invert this out.
So right at the beginning, I say radicals, always check your answer. There's two math calculations, a radical and a log, which we'll do in chapter 3, that you always have to check your answer. And that is because the domain, what's a domain? What does that mean? What x can be. So with a radical, there's restrictions on what x can be. What is the restriction with a radical? On a square root. It has to be a positive number or 0 under the square root. You can't put a negative. That's a restriction. So the domain or your calculator won't let you plug in a negative under a square root. It'll say error. Okay? The only other math calculation that does that is logs. It has to be positive to be a log, too. Kind of the same as a radical. Except a radical, you can have a square root of 0. And a log, you can't have 0. It has to be only positive numbers. They're the only two things in all of math that sort of have a restriction like that. So you have to check your answer because sometimes, I'm going to show you when it doesn't work. You get an answer that works without the radical sign, but when you plug it into the radical, it makes a negative underneath. And you say, okay, well, that didn't work. So first, let's do radical equals radical or not. So two types in one. And we're only doing square roots, but the method will work the same for different roots. Okay. And the checking part makes the question worth more because it's more steps to it, but also usually it's fractions in it, so you have to do common denominators and things to check your answer. Okay, so any ideas? How do we solve for x here? Square both sides. So whenever you have a radical or a square root, you square both sides to get rid of it. That's the method going to be for everything. I'm going to write it in a second line, but you could just write squared squared. I'm writing it in a separate line so you can see this was the question and this is how I solved it. So you square both sides. And a squared and a square root cancel. So what we've essentially done is canceled out. But if the x value makes it negative underneath, it won't be a real answer. And that's the idea. So some of these have an answer, but a lot of them don't. So what we would now do is just solve this. So 2x minus 4x, 1 plus 3, moving the negative over. X equals 4 divided by negative 2, which is negative 2. So where does this negative 2 actually work? If I call this line 1, this line 2, this line 3, 4, 5, 6. So we have 6 steps that we did here, 6 lines. Where does the -2 work along here? Right here in number 3, when there was no radical. That's what we just solved, was this equation, number 3, and we solved it, we get -2. So if we put the -2 in here, it'll work. Both sides will be equal. But what you have to do is check the original question before you changed anything. Does this make a negative under the square root? If it does, then it's not actually an answer, and there's no answer. So we need to check into the original question before you changed anything. So that's always that first line before you square both sides, before you do anything, you have to plug your answer into that. So we're going to take our x equals -2. Now, to plug it in, so the x, we're going to replace all the x's with -2, so this will be 2x minus 3. I just put a bracket in there instead of the x. So when you're going to check an answer, wherever there's an x, you take the x out, put a bracket in, and then put that -2 into the bracket. And then you've got an equation to solve. So 2 times -2 is -4 minus 3, which is -7. Is that possible? No. This one ends up with the same thing under the radical. But this is not possible.
Which we did the question right, but
Right, the question you did right, the inside of them were equal, but it doesn't work in the original question. It only works up here in step 3, which will give you -7 equals -7. So you say that x equals -2 is inadmissible. Therefore, no solution. And I want you to write this, and I even put it as instructions on the assignment to write that it's inadmissible, because later on when we do harder ones, you might get 2 answers. One of them will be inadmissible, not work, and the other one will work. So here we're just going to get one answer. It either works or doesn't. But later on in the course, we're going to get 2, 3 answers, and some of them will work and some of them won't. So some of them are inadmissible. You throw them out, and the other ones work. So we're going to write that it's inadmissible.
so if you get a negative value halfway through verifying it, you have to still continue going through.
Okay, so a negative, I'm going to comment on that. Yeah, you don't really need to, but if you don't carry through, if you just did this side and said that doesn't work, what if you messed up here and that was actually a different answer? You're going to be checking your answer and say, well, I got the same thing under and they both don't work. I did get the right answer, it just isn't a good one. But if you ended up with 2 sides not equal, then you messed up above, and so your check told you that you messed up. Do you know what I'm saying? Like, whatever's under the 2 radicals should still be equal, even though it isn't a possible answer. So it is good to follow through with your check to get both sides and see what you have, because it will help you. Now, my other comment that I thought of when she asked that was here. A negative answer doesn't mean it's not going to work, because you can plug a negative into something and get a positive, right? So don't just say, oh, that's -2, you can't have a negative. Sometimes the answer is negative, okay, and it will work, and, there might have been 2x plus 10, and you plug a negative in, and that'll give you 6, radical 6, which is okay. So you can have a negative answer, just not a negative under the radical. Okay, second question. So here I've got a 2 in front. So we have to use our rules of exponents when we do this one. So we've got a radical equals a term that has a radical in it. We're going to square both sides. You have to square the whole thing, not just the root. So what do you do with this 2 in front? If we have a, b all squared, then that's a squared, b squared. You have to square both. So this will be minus 3x plus 7. This will be 2 squared, and then that squared, which makes the radical disappear. So minus 3x plus 7. 2 squared is 4, and x plus 4. Right? When it's a root and a square, they cancel. But this squared has to go into both things, the 2 and the root. Okay, so we've got this minus 3x plus 7 equals 4x plus 16. Solve it. Sixteen minus 7? 9. So x equals minus 9 over 7. So I did it on purpose to get a fraction, so we have to do a common denominator. I moved the negative up to the top, yeah. All right, we don't leave that on the bottom. Okay, so we have to check this, and it kind of sucks because it's not a nice number to plug in, and we all have to do a common denominator, but it's good practice for that part. So we're going to check. So write your number that you want to check, and then both sides of your equation. You always go to the original before you squared anything, before you moved anything around, before you did anything. It's always the original question that was given to you. Take out all your x's and in their place put a bracket. And then in the bracket put your number. We'll do one side at a time. Okay, so when you minus 3 times minus 9 over 7, how do we do that? This is like a 3 over 1?
Multiply 3 by 7.
No.
Yeah.
You multiply the tops and you multiply the bottoms. Negative times a negative is a positive. 3 times 9 is 27 over 7. When you have a fraction times a fraction, you multiply the top, you multiply the bottom. You do not multiply 3 by both of them, because then that's like multiplying by 1, not 3, because 3 over 3 is 1. You only multiply it on the top. You want to triple whatever is on the top. Plus 7. What's the common denominator? 7. So we need to multiply this one. So 27 over 7 plus 7 times 7? 49 over 7. 27 plus 49. 76 over 7. Now just leave it like that. Because what should happen on the other side is hopefully the same, but we've got a 2 in front, so I'm going to show you how to look at that. But this is okay so far, because it did give me a positive. Right? Alright, so let's see what we get over here. Now this is just minus 9 over 7 plus 4 over 1. What's the common denominator? 7. Uh, 28 minus 9. Alright, Now, they don't look the same right now, so how can we check if they are?
See if you can simplify the first. Multiply that. Well, because it's 0 to find out that we square root of 2 and 4.
Okay, someone up here got it. I know you aren't all going to get it, and that's fine, because I'm going to show you how to do this. What if we either want to take something out of here to make a 2 in front? What would it have to be under the root to take it out to be a 2? 4. So the question is, does 76 divide by 4? And you can look at that, or, but let's not worry about that right now. How would we put a 2 under a square root? Right, a 2 out of the square root is a 2. Under a square root would be a 4, right? Square root of 4 equals 2. Out of the root it's a 2, under the root it's a 4. So if you have a number that you want to put into a root, whoops, square it. Okay, now it's under, and we need to see if that 19 times 4 is 76. That's what we're wondering. Does that make sense? We have a 4 here. 4 times 19 over 7. So does 4 times 19, I'm going to do this out because a few of you I saw tried to do like 16 times 6 and failed miserably at that on the test. So how do you do multiplication? 4 times 9, 36, you put the 6, carry the 3. 4 times 1, 4 plus 3. 4 times 1, 4 plus 3, 76. Okay, so that checked. So what did you learn right here? If we want to put a number under the root, what do we do? Square it. So if there was a 3 under the root, out of the root, what would it be under a root? What's 3 squared? 9. If there was a 10 out of the root, what would it be under the root? 10 squared, 100. Right? So you can, just like you could take the 4 out of the root and make it a 2, you can put it under if you square it. Okay, so we'll stop there. We're going to pick up with radicals on Monday, and I'll have your test to hand back. The questions are there, and there's tons of them, because I think you need more practice. There's like 20-something questions for the homework. And the homework's due Wednesday. So I would start it over the weekend. 1.4, yeah. Do not leave that to the night before. You'll never finish it.
Inspired by Jungle Gym? It is, right? It's like Jungle Gym? Yeah.
There's a cube root on one side, square root on the other.